Hey everyone, welcome to the SIG-Auth community meeting. Today is June 4th, 2025. This call is recorded, will be published to YouTube. It follows the CNCF Code of Conduct. Uh, so we have two items for discussion, and then we have one demo. So maybe we can start with the demo. I think Lucas.
Yes, thanks. Yeah, and it's a demo and kind of also a discussion item, I guess, of what if we should go forward with a CAP for this in this form for the conditional authorization feature. Let's see if I think you need to approve the share screen requests for.
Done.
Yeah. Okay, cool. Seems that I have it now. Can you see my screen?
Yep.
Okay, cool. So, well, some time back, well, this is about conditional authorization, and let's see how we could use some of that. The background here is, well, as some of you know, I've been in the Cube community for a while. Since a couple of years back, I'm also doing my master's studies, which sadly reduced the time I have for upstream contributions. But now I joined Upbound, so as part of my master's thesis, I figured that I'll do something that combines all of them. So I wrote a master's thesis about how we could do some of the conditional authorization implementation upstream. So PLDR, two things I want to touch on here, and I've already discussed it with a fair amount of you at different KubeCons and stuff, both in London and Salt Lake City. For example, Micah made for Salt Lake City the kind of an integration between CEDAR and Cube. But one of the first, the contributors on it, one of the first things David said was like, it still has like two different types of actions. Can we make it uniform? So I've taken a look at that. Been obviously a lot in touch with Micah and figuring these things out. And on top of this, one of the common problems is that read and writes, or admission is only for writes, not reads. So figuring out a better user experience to kind of be able to reuse policies between those. And those both fall into the same areas, but practically. So now I'm only gonna, for this unified authorization and admission, I'm only gonna focus on those things, those types of admission things where you actually want to bind it to a principle. So like all of the, like compliance stuff, with Cell or like, Rego and Kyverno and stuff like that is not kind of in scope for this. It's especially like specifically for those where you want to, do something with the principle at admission time. So want to that. Then a couple of issues that kind of I started looking at these label selectors, cohesion, RBAC policies for kind of more fine-grained stuff. So a little bit of background, we figured with Micah that some of the things you might know of, but some it could be good to level set. So we want to have like an authorization engine needs to be expressive, fast, safe, analyzable, and correct, of course. So where does the existing things in our ecosystem, fit on this? So we have webhooks, which are super expressive, but we can't know if they are fast, safe, or analyzable. Then we have VIP using Cell, which is nice, and then RBAC, which is not as expressive. So like we have this gap between admission and authorization. So I was thinking about how we can solve that. Also, webhooks are not available in cloud providers. So you generally like a Helm chart or something like that can't depend on a webhook existing, those semantics. So again, as you know, like this leads to kind of over granting permissions in RBAC usually. So if I want to say that Lucas can only create, update, delete gateways when the class is test gateway, then I need to kind of grant the whole thing in RBAC and then remember to take it away, which is, an admission, which is not atomic, for example, and stuff. We can do it, but it's not a super user experience. There are some other examples. DRA, admin access, this kind of ingress gateways listing all secrets. Now we could scope that down to TLS, at least this kind of class example, binding node agents to see just CRDs with some predicate, for example, spec node name to the bound node. CSR signers, we today use compound authorization, but another way to do it would be like literally to say that, well, if you have the ability to, you can sign, or you can create a CSR with this signer name, and then like all in the same kind of expression. And then finally, impersonation has been discussed a little bit. So with this also, like the impersonated user essentially becomes a resource, and if we can have kind of an expression of the like what is like what do allowed impersonated users look like through this expression, then we could also like solve all of these 6 with one go. And this is just for the kind of unified. There's, as per the RBAC++ discussions, there's also stuff we can do on the resource attributes with more expressiveness. So these all boil down to label and field predicates, the selectors, basically. And this solution that I present here, conditional authorization, is also a superset of the kind of selectors for all verbs that we've been discussing in previous meetings. And there was an idea of making that a cap as well, but this is more generic and would kind of cover both cases. So if we go back to this, there's a Turing completeness wall that we can't kind of cross, but there's another interesting kind of analyzability wall as well. And whatever we would like to do, I think most likely we would like to be analyzable. So what is analyzability? I think most people are familiar, but again, to level set, propositional logic can be solved with SAT solvers. Only Boolean variables allowed, always decidable, no quantifiers allowed. But then when you go to kind of more complex data types, it's called satisfiability modular theories in first order logic. Then you can have Boolean strings, ints, objects, arrays, sets, functions, all kinds of stuff. You can also do comparisons of integers, addition, whatever. And then you have quantifiers such as for all and exists. However, already in like almost 90 years ago, Church and Turing realized that if you have these quantifiers for all and exists, then the problem becomes undecidable. So you can't analyze that, you can't know it's essentially the halting problem. So if you want to kind of constrain this, like cell can do loops, right? When we kind of look at how many ticks it does, and then cut it at some point. But if you want to analyze it and make sure, like make sense of what it's doing, you can't have loops and no quantifiers, basically. So if we kind of restrict, so we don't have, for example, loops, quantifiers, and stuff like that, what do we get? Well, we can, for example, order the permissiveness of different policies. So like we can check for logical inconsistencies, for example, a deny rule which is always greater, strictly greater than an allow rule, or another allow rule which is strictly greater than allow rule, or check for equality. If you're refactoring, maybe you want to check that the policy you had before and the policy you after are actually the same, even though you expressed them in another way. Or the most kind of concrete for our use cases here is that if we have conditional authorization, it actually allows us to check for privilege escalation prevention in a generic way without kind of building it all ourselves. So, well, Kubernetes uses a lot of cell. What of cell, like just I took a quick look today at the spec, should be analyzable. So the good news is most of it, I think, should be. I'm not like I'm a couple of like 4 months maybe into these things, so I'm not an expert yet, but fairly confident that these are. I've been writing some SMT, so yeah, no loops, no regexes, but almost everything else should give us analyzable stuff. So, and to be honest, it's great. Like we don't want to have loops most likely in an authorization anyways. I don't think anyone really like proposed that. But this kind of helps us as a guideline of like what do we actually, how much expressiveness do we put in these things. So no float either. And if we maintain this encoding into decidable SMT, then we get this kind of analyzability for free. Another kind of side note, not the main point of this proposal, but there's also this kind of discussion of like how much of cell, like what cell subset should we allow as a new unified selector type. And this might, if we decide on a subset of cell that would be used for authorization, it might be just the same syntax kind of for this selector type. So let's talk about this middle part then, like more expressive than RBAC, but still analyzable, right? So let's divide it up into write and read requests. Let's start with write because that's easier. The idea here is that, and I mean, label selectors and field selectors have been discussed many times before. There's always been good reasons for not doing them, and there might still be good reasons for not doing them. But one way that, to my knowledge at least, hasn't been discussed before, like, well, in the RBAC++ meeting that I watched this morning, there was discussion about conditional authorization, but in the issues and stuff, I haven't seen it before, that you can have at the authorization stage, you actually are able to write a unified policy, which touches both on the attributes and the object. And then you do a partial evaluation, which means that you might arrive at a yes or no or a maybe. The maybe is then like, because you don't have the object at this authorization stage, you know that all of the maybe expression will kind of only apply to the object that was unknown at this stage. And then, so what it looks like, for example, is that now I've been using CDAR for some of this experimentation, but other things also most likely apply. So like if we have user Lucas trying to do a crate on persistent volumes, I know at this stage that I'm in TMA, and I know it's a write request, a crate request, so I know that I have a payload. So then all of these kind of first, what is it, 5 fold down to true, and then the only expression we have left is that, well, is the persistent volume spec is a class name slow HDD, and that is the thing that we take. Then for either the API server to enforce, if we extend subject access view with this, or then for an admission webhook to enforce the kind of demo we have at the moment. But we might get an unconditional allow or deny at this point already. Cell has some support for this, but I haven't tested it. CDAR has support for this. So now at the admission stage, if we got a maybe, we can continue, we decode the object, and then we can, well, obviously know for certain that is it yes or no. So we could probably build this in a kind of forward compatible way and backwards compatible way by having some, well, feature flags and an opt-in on the subject as review. It could be either like we keep an allow plus a condition, or add a new type of decision, string to the enum, something like conditional. Open to different ideas there. And then if Kube API server is the one that enforces it, or if like the webhook enforces it. That's also up to debate, but most likely it would be good to, if for users to actually be able to depend on it, most likely in the long run, Kube API server enforcing it would be nice. So a high level view of what we have today and what it could look like. And now, like, this is referring to the meeting with RBAC++, basically. So for cluster role bindings, at the moment, only target username and group, as we know. Maybe namespace, roles, target attributes, but then in VIP, you have basically everything. You can target everything and have a lot of expressivity, arbitrary expressions and stuff. But the applicability is only for writes. Now in the new, like, what could be done with what I implemented as proof of concept is basically, now I just write it here as unified authorization, but we could call it whatever, that can target all of the user info. It can target the kind of object itself, the new or the old object. At, like, from the policy author's perspective, can target, then the system figures out, when to decode and uses this partial evaluation feature. Now we have more expressivity in terms of operators, arbitrary expression, but it's still kind of it kind of targets, it's on a per object level. And now we have it for both reads, writes, subject access view, and custom verbs. Other ways of doing it, like we can discuss this later, go back to this slide, but like, we can still, if we want, it doesn't have to be a single object. I experimented with it as a single object, a single policy, but we can split it up to kind of have a role binding and a role differently if we want, and maybe some bindings between them. But anyways, so that's how to unify, like, the write requests. The read requests are a bit harder, but they should also work. So from the RBAC++ discussion, this was an example of how we could constrain the type. So there's a field selector called type, operator equals, and then it should be my type. But this, like, if we make it kind of, if we just expose the field selector and label selectors as is, it's really hard for the policy author to kind of, they have to write in some way for a write. They can just write object equals type, my type, for a write, but then they would have to write this for a read. That is not super user-friendly. So, but I think I found a way to be able to do object type equals my type for both reads and writes. So how does that work? Here I visualize an example of two authorizations. So one authorization says that if the environment is not production, like for example for labels, and labels owner is either team 1 or team 2, so then it's this box. I don't know if you can see my cursor, but hopefully. And then, or then the principal is allowed to do something if the environment is test. Okay, so there's 22 different label selector kind of pairs that you can, if I counted correctly, that you could make that actually fit within this green area. How do we make sure that when we have a request, one of those 22 requests, that we actually are able to, from this high level representation, actually figure out if it's allowed or not? Well, one way would be to enumerate it, like, naively. If we see a label selector that says owner in team 1 or team 2 and environment in test or dev, if we see that in the API server, we could just kind of take the cross product of them and test each and every one of them. That, is this authorized? Is this authorized? Is this authorized? And this the final one. And we see in the area here that, well, it's all green, so it should be authorized, and it is. But now, if we would move the box a little bit to the right, we now say that owner is team 2 or team 3, and environment in test or dev. But team if owner is team 3 and the environment is dev, then we don't have access. Here you can see that the yellow box selects something that is red. We shouldn't. It could match. We don't know what objects are in storage, but it could match something in storage which wasn't authorized. And this we actually can turn into SMT logic and solve with a solver, like SMT solver. Now the solver will give us this output, say that, well, actually I found a counterexample of like dev, environment dev, and owner team could be returned, so it would be unsafe. You should not allow this request because I found a counterexample. So yeah, and the explicit enumeration also falls down in the part where you could have not, so star minus. Then the amount of possibly selected objects is infinite, and we can't enumerate kind of explicitly. But we can turn it into logic. So if we see a label selector at authorization stage, we send it to a kind of, we turn these into logic. We do a partial evaluation. Again, we might get a yes, we might get a no, we might get a maybe. If we get a maybe, we know that, and this is again a read, then there were label and field selectors in this request that we need to kind of figure out, are they allowed or not? And we also have an expression, a residual from the allowed policies of like saying that, okay, you can list with these labels. The safety property in this case is that for every object that, in the whole universe of every API object that could ever exist for this type, if the object would be selected by this request, and this we know from the selectors, then also, like for all such objects, it must hold that it would also be authorized. Again, like this for all objects here is a infinite set, so we can't do that. But with a solver, we can actually do the opposite. So the inversion is that does there exist something where the object would be selected, but it would not be authorized? That same object would not be authorized. If we get a satisfied result, it's unsafe. But if we manage to find out that this is never possible, then we know that all of them are actually covered by the authorization. So an example, or the same example that we had from before, the label selectors are turned into this one, just like labels.env in test or dev, or owner in team 1 or team 2. Now we put this to the solver, we get unsat, and that is correct because all of them were within the green area. So yes, these two approaches we could use. I implemented a proof of concept using CDAR for this. There's a good paper on CDAR I highly recommend from Amazon, and how they implemented it. A quick intro. It's I'm not affiliated in any way. I'm impartial in this matter, but yeah, CDAR is a generic authorization engine, open source, aims to kind of solve these in a generic way, expressive, fast, safe, analyzable. It maintains, the nice thing about it is that it maintains a decidable encoding into SMT logic. It supports RBAC, feedback, and ABAC paradigms. And then, well, crucially, Amazon is donating CDAR to the CNCF. There's the CNCF sandbox issue. So yeah, hopefully whenever the next TOC meeting is, we will have, they will get into the sandbox. What is unique about CDAR as well is that it's fully formally specified in a mathematical language called Lean. And then there's millions of test cases generated from the mathematical model such that you can kind of test it in a very rigorous way. So what is nice about CDAR is that, well, you get syntax highlighting, autocompletion, validation. So if I typo namespace there, it's going to tell me that, well, you did a typo. Did you mean namespace instead? And this is done by reading OpenAPI discovery, all of that, turning into a typed, CDAR is typed, so turning it into a CDAR schema, and then the VS Code integration kind of handles the dev loop with the policy author. Next, we can write these policies that kind of combine. So I can say here that, okay, Lucas is a user. Lucas can create, update, delete gateways whenever gateway class name is test gateway. I'm able to say this in one policy. Again, we can split it out if we want. Don't have super strong opinions there, but it's at least possible to write it in one. And now the same example, but now I actually can put action any. So this will actually apply to reads as well. So I will be able to do, with this policy, I will be able to do a list request for gateways where gateways class name is test gateway, and it will be authorized. And then the analyzability layer is nice. We can check if the old policy is larger than the new one. So it helps with privilege escalation and all of those kind of things. And this kind of cell and CDAR integration, I think, is really nice. CDAR kind of, because it compiles down into SMT, we can just use the kind of common subset of cell and CDAR syntax. Take, if we call this smaller subset authorization cell or something like that, we can have a front end that is cell, turn it into CDAR, and then recursively turn it into SMT. I mean, we can, of course, make a mapping from cell to SMT directly as well, but the PR that for CDAR to map into SMT is still 33,000 lines of code. So it's, some work to do. It's possible, but some work. So then this all boils down to something like this, maybe, that we can have like multiple different frontends in quote unquote, maybe something selector based that kind of protects users in a good way. I mean, one of the main reasons for not doing selectors before is it's super easy, and it still is super easy to shoot yourself in the foot. We can make some, front end that is user friendly, that actually, like takes care of those edge cases for you, but they all kind of use the same analyzable layer. They all use the same whatever syntax we agree on as a core analyzable, set, expression set in the conditional authorization in subject access review. So yeah, that's the takeaway. I think that this should work, and we can move forward and make a cap of how this could work in more detail. But I already did write 60 pages on this matter in the thesis, so feel free to go and look at the thesis at luxa/research on GitHub. If we restrict ourselves to SMT analyzable expressions, we can have arbitrary frontends. Some people like cell, some people maybe want to do CDAR, or maybe something else that is still within that subset. All works. If we do this, we wouldn't have to do the privilege escalation stuff ourselves. We could use a solver for that. CDAR policies are nice in that they actually give you a hot loop validation flow. And now we can provide users with a uniform experience across both reads and writes and authorization and admission. CDAR, has already solved some of these things. So if Cube wants to do more advanced authorization stuff, we could maybe use some of those things, those good tools that CDAR already made when CDAR is in the CNCF. So yeah, I guess that's the end, and now open it up for questions. David?
Yeah, apologies if this flipped up. I didn't see a link to the slides, so it might have flipped up and didn't stick in my mind. But when one of the challenges that I had seen with the CEDAR approach is you have a set of CEDAR rules, and it's very important that the set of rules that you start authorizing with at the authorization layer is the same set of rules that you use to confirm the bits are correct in the admission layer. And so how do you see us sharing that information today, or sharing that information if a CAP were to be written on?
Yeah, so at the moment, it's a good question, and we already spent some thought for it. Well, if the kube authorizer takes care of the enforcement of the conditional expression, so like basically at the moment, like when it comes to authorization, the subject access review goes out to the CEDAR authorizer. A CEDAR authorizer decides that, well, you are allowed if gateway class is test gateway, right? Then it returns in the subject access review, it returns this condition in a format that kube understands, and then kube can use that. Kube doesn't have to hook out anymore. Kube can just use that and look at the object and says that this doesn't fulfill the expression, so it was not authorized, right? If kube does it, then that is a way. If we have to do this, I had it. Let's go back to. If we have to do it like this, then we would like to have a context key between authorization and admission. I hacked up a like dummy PR for that. Like I didn't publish it, but a proof of concept for that. It was not many lines of code. But then in that case, we actually would save the partial evaluation kind of residual on the webhook side, and then we see when the admission webhook comes, then we just see that, okay, it has the same key that we already had a residual for. Now I don't need to fully reevaluate again. I can just look at the residual, like this one equality check of like, is class equal to test gateway or whatever I had. Then yeah, that ensures atomicity.
Okay. I think that's probably my primary interest in a CAP, is trying to find a way to tell generically anyone how to do this. And then potentially we use the same mechanism inside of Kubernetes for some purpose. Probably some sort of proof of concept would have to get built in order to have sufficient integration testing to really have confidence in it. But I think that for me is that key bit that if Cube doesn't do it, I don't see how someone can successfully overcome that not being present.
Yeah, no, I agree, and that's why kind of like this works, right? At the moment, this kind of just like when we set it up exactly the way it should be in kind and whatever with webhooks, then it works, but it's not practical. Yeah, no. If it's not in core APIs or actually enforcing that condition, it's not practical. Yeah, and that's why hence the CAP.
I guess kind of related to what David just asked, like, so I can see how the context thing works out for a webhook, right? But what if you want validating admission policy to do the rest of the enforcement for you?
So this is all like this all complementary. Again, like I don't want to do the context thing, right? I want the authorizer to return an expression, say that only allow, like it's a maybe, only allow if this holds true. Then when the API server has decoded the thing, it just like reject the request immediately if it doesn't hold, these things. However, then it's complementary to all of the other stuff. So as I said, like you might still have compliance, stuff like no non-root containers in my cluster, right? It doesn't really belong to any principle. It just like applies to everyone. So like all of that still holds, all of that kind of still runs. But after the object is fully mutated, then the API server could, because it stored the expression that was returned from this authorization stage, it can enforce it directly without doing a single webhook in the, from there. Does that make
So
sense?
are we saying that we don't care for use cases that are based on externalized state, right? So the use case I'm thinking of is like a kubelet can read the secret because there is a graph that allows us to quantify that there is basically a path between a set of resources that lets it get to the secret, right? So that exists as a a hard-coded graph authorizer within Cube, right?
Yeah.
Are we saying that we don't care about such use cases where it's not just the principal and the request being made, there's like some extra state, right? And so like, VAP can have bindings that, refer to like custom resources. So I'm thinking about those types of things where it is about the principle at hand, but you can't tell the answer just by the principle and the request being made. You have to look at some amount of externalized state to make the yes or no decision.
But can you do that already in the first webhook? Or do you mean that you want to have a function in the cell or whatever that would actually kind of look things up?
I mean, somehow I have to express this, right? So like as you mentioned, right? Webhooks aren't a choice on the cloud providers, right?
No.
So how do I express this in some way that I could realistically make like a Cube API for at some point?
Yeah. The good thing is that Cedar, at least in its model, has like a graph, like you can have a DAG. I mean, you can't do non-DAG things in the cyclic graphs, but as long as the thing that you have is a DAG, you can encode it. I think the hardest part is like how to teach declaratively how to stitch like how to configure the API server to say that a node and a pod are bound to each other, and and when you see a pod, like this is how you should figure out where the service account ref is, and this is how you should figure out where the secret ref is. Like it's possible to do, right? It's I think should be pretty easy to do for like express for the policy author these things, but the hard part is like how do you teach what the dependencies between your objects are declaratively. And that I think that like for that maybe like full-blown cell expressions could work, right? So like that was an idea that I played with. So like you have and I implemented some proof concept, like you would have some kind of mapper that takes, say, a pod, and then a full pod, right, object, and then it somehow maps that into like what edges are there from using a cell expression, like a full blown with loops and everything, maps that to like what edges do you have to other objects, right? Then you have to do that before you do the before you start authorization, or before you start this final authorization stage, say. You have to run that, and then you can give the graph fully resolved, give the graph to the authorization expression, and then it's simple for the policy author. It could just like if the resource is a node, then you can say resource dot like payload dot service count refs or something like that, fully dereferenced all the way to the service counts. That is, yeah, if that is interesting to people, like I can go and explore that more. I think it should be possible to do most of what node authorizer does using this thing. I think the hard problem is like, yeah, maintaining the consistency of a graph, like doing all of that work, which Cube API server would do. But I mean, it's already doing. So now it's a difference of like taking the hard-coded node authorizer logic and making it expressible using something like cell. Does that make sense?
Yeah. I'm trying to think of like, where the bounds of what we want to express are. I have a different question. That is, did I understand correctly that one of the things that you were proposing is expanding the expressiveness of labeling field selection with cell? Did I understand that correctly, or is I missing
It was
something?
kind of it's like side note that like there was discussions on like do we like I think James Manale was the one that kind of brought up like making field selectors on par with label selectors. Then Joe came in on this thread, like one of the cube issues, and said like, let's just make a new selector like format. Let's base it on cell, and just call it a day. Like, but then the conversation stagnated after the point of like, okay, now we need to decide which subset of cell do we allow, right? And my point with this was that we need to, for the authorization purpose, we can't do all cell, full cell. We need to scope it down without loops and make it simpler. Maybe this more simple thing is actually the very similar to what the expressiveness of a field selector or like a unified selector would be.
Well, I'm not sure, like, need to scope it down. Like, those are some pretty deep cuts there. All exists, none. Like, you're kind of giving up the ability to look at containers within a pod or other things that I could very much imagine that people would be interested in writing authorization policies for.
Yes. Actually, I have all the way to the end. Anticipated question from SIG-Auth. This is one of them somewhere. Or no, actually, it was on this slide. Yeah. Sometimes the semantic property is deeply nested in the object. And then this conditional authorization layer would be unable to check it because we don't allow loops in this phase. Again, this is complementary to like we can't solve everything with conditional authorization. We can't solve everything with analyzable stuff. The idea is that like if we can solve most of them, then that's good. However, one thing to like work around this is to actually at the API level add something of like allow insecure property, whatever. And then at the API validation level, you can only use the insecure thing or like the whatever authorization is like interested in, which is deeply nested. You can only use that if the top level kind of enable thing is set. So then you are able to, in the kind of the policy author is able to just say like, admin access, yes, no, like this user, admin access, yes, no. But then if admin access is yes, then some deeply nested stuff might actually, some complicated logic might happen, like be allowed in the API validation level. But then if it's no, then like all of those insecure stuff would not be possible.
I would flip it around, right? Like, what I'm not convinced of is that it's worth making that sacrifice to gain SMT analyzability. Because like SMT analyzability is not something we can put on a hot path, right? It's exponential, even if a solution is found. So like, what would be the practical use case?
What do you mean? Just what do you mean by exponential?
I may be wrong, but I believe it's not like given a given number of bits of SMT input, the runtime that you take to decide whether or not your thing is satisfiable is not polynomial in the number of bits. It's been a while since I was in grad school, though, so maybe I'm wrong.
Yeah, so like maybe I can clarify that like SMT analyzability is not used in the hot path. In the hot path, it's basically like the same as cell subset, right? But it's useful for preventing privilege escalation, right? But yes, it's one of the questions, right? We can do full cell, right? It's possible. The question is like, is it worth it that we then can't compare policies? Is it worth it that we then can't know if someone privilege escalates or not? That's the trade-off, basically. Well,
So I think one, I want to give at least some time to the
yeah,
other topics. I want to stop here, but I think what I'd leave you here is I'm not sure if the analyzability is important enough to give up the expressibility. And I think perhaps we would take a middle ground approach where we would ask you to express certain bits in the same way that we ask you in RBAC, which are, very simple and straightforward, and are, privilege escalation checks capable. And then the rest of it, if it's, full-blown cell, it doesn't get checked. So we assume that, those are going to just be, we don't allow the cell to grant a permission, basically. Can only restrict what the rest of the sort of payload has allowed already. And I think you can get enough of a partial check there to be okay, I think. But yeah, I just, as Tahir was saying, I don't know if we could come up with a useful system that people actually want to use if we can't like poke into pods and stuff, which is what people want to do.
Yeah, you can still poke in the pods in admission, but yeah.
Great.
But yeah, let's thanks. Then let's move to the next.
Thank you.
And yeah, please reach out if you're interested in discussing these more.
Okay. Two discussion topics. So the first one we added, so we were doing the SIG-Auth triage, and then we saw this PR and the issue out there. Basically, this is to deprecate the image policy webhook admission plugin because this has been alpha, like I think since 126. I did see a few comments on the issue yesterday about also adding this to like API machinery meeting. So I just wanted to bring it up here and see what folks think. Yeah.
I haven't even looked at this in a long time. Is this the one where you actually write a configuration that says which hook to contact, and then the hook gives you back a yes or a no for the images in the pod?
Something like that, yeah. And the internal API between the webhook and the API server is some alpha schema that we haven't touched in 2016 since, yeah, almost 9 years. So it's one of those like alphas, but has been around forever kind of things.
Yeah, I'm probably inclined to remove it, but I would like to do it in a way where the first time we go and remove it, someone can actually turn it back on, right? So like we basically hide the whole thing behind a new gate that you have to turn on to be able to access that admission plugin, so that anyone using it gets upgrades and they fail and they know, oh, I don't have to rewind. I can set this gate for one release, fix myself, and then move on. Does that work?
I don't know if I have a strong opinion. I think Bitch Jordan was here. He tends to have much stronger opinions on these types of things.
Yes.
Maybe we'll just punt this again, Nish. Let's see what Jordan says when he gets back. I'm sure he'll be like, no, don't ever deprecate anything.
Right.
But yeah, I don't know. I don't know if it's like I don't think this is like urgent or anything. So I think
Yeah, it doesn't hurt me. I haven't had to maintain it in any long while, but I'd be happy to see it go.
yeah.
No. And then the second item was this. So I think Micah or Jyoti.
Jyoti. So I manage clusters for a living, and I'm managed many cloud provider and manage many thousands of them. The interesting part that comes out of this is there are many kind of authentication policies on the cluster. as part being a cluster admin, I write my own controllers, and they are co-located with the API server because of the nuances of the architecture. And when we do that, then there's a potential possibility of malice. Let's say that I write something and I inject a certificate and I keep using it because certificates would expire. They could, they have some limits, but they are not, they tend to be long-lived than tokens, bearer tokens. So given that, the thought here was, could we have some possibility where through structured authentication, we could bound these co-located controllers to still use certificates, but nobody else in the system can. So if a certificate gets spoofed or leaked, it it has to be used in my model on the same box beside the API server. And this is where if somebody cannot get into it, they cannot use the certificate. So yeah, that's the premise of the problem that I'm thinking around. So thoughts?
I'll add a little more color too. Like it does feel like it can sound like somewhat circular logic, like okay, you don't trust the API server, then why are you like even using this, right? But basically the core need we have is to tie specific authentication mechanism to a specific network. In our case, it looks like, we want a specific X509CA to be localhost only, but seems like something that could be generally useful for other authentication mechanisms, ideally in structured authn.
Speaking selfishly, as somebody who works on GKA, we definitely wanted that for tokens.
Yeah.
Then I thought about how we could actually express it in an upstream open source way, and then I gave up on the problem.
Yeah, our need, our most like imminent requirement is for X509, but could be extended easily to any other sort of authentication format. Ideally, and the thought being, if we have structured authn, it's another field in there, and it doesn't necessarily, it's not something that an authenticator decides, it's something Kube API server decides, but it's a configuration option.
I was thinking about it the other way, actually. So a model where the credential itself contains a claim that says, don't trust me unless I came from this IP or this network. And then you restrict what credentials you issue so that they can only be...
Yeah, this is more about like configuration for the cluster itself to say, I trust this authentication mechanism, but only over this network.
Okay.
Like if you had a one X509CA that was for internal networks only and another that was for external, you might want to be able to enforce that. Say you have like one that's hardware backed and one that's not, and you say, okay, this non-hardware backed one, I need to use it for processes on the same box, but I don't want that to be like exportable off host, right? Or a local one that's not hardware backed technically could be exportable, but in this case, yeah, now the request couldn't be made from off box. Yeah, Mo.
Remind me, do you guys use a request header proxy?
No,
Okay, so no request header proxy.
I don't think that would apply to this because you could sort of probably decide some of that in the, if you had request header.
Yeah, I mean, so traditionally these types of requests, right? We basically said if you want to do something this fancy, you use a request header proxy and have it enforce whatever magic criteria you decide relevant. So I would be inclined to say that is the way I would expect people to do it. Obviously, the request header proxy itself is an MTLS connection. So that's maybe a little awkward. Yeah. We don't have any authentication thing today that's dependent on the network outside of, or that can enforce anything on the network outside of request header. Outside of request header. And we have the anonymous auth thing now that can do path stuff, but that's it, right? Everything else is basically cert based or token based. Yeah, so I feel a little weird about this just because I'm like, if don't like I don't know, don't lose your certs, use short-lived certs or whatever. Like, I mean,
It's not really about losing certs. It's more about like just assurance that like of non-exportability for in this specific case for certs. But yeah,
I mean, couldn't you just use an HSM then if you wanted to make sure that you couldn't export the cert, like
I
attach
mean,
box?
yes, there are cost implications for that, but yes.
Okay. Yeah, I'm not saying using HSM is like fun. I'm well aware it's not.
And that's sort of the point of this is to say like an HSM backed one could come from any network, but a non-HSM backed one, we might want to have more constraint to local only.
Yeah.
I did this run this by Jordan. I won't speak for him, but he was sympathetic to this and didn't sound. I'll let him speak to us later, but it didn't sound like a bonkers idea.
Yeah, no, I understand network binding. I'm not not super opposed. Like I don't necessarily like the framing of how this one is framed. Like it's I think maybe a little too specific.
Yeah.
Um I think you'd also want to describe a generic version of this is more about like if you think about the Go interface, right? It's authenticate request, right? And the entire request comes in and the whole response comes out. We're saying now that instead of just the bearer token or the certificate, we want other parts of that request to become externally usable as part of a configuration. So I think that's where you have to sort of define what pieces of that you're wanting to be able to poke at and then how. The obvious thing that comes to mind is cell. So, just in the same way that we expanded the OIDC stuff with the new job authenticators in structure.then to let you do basically arbitrary magic with cell on the token payload. I guess we could expand cell to let you do arbitrary magic on the request. I mean, payload's not the right word, but request metadata.
Size. Yeah. Metadata. Right.
Um,
IP size. Yeah. Network.
the the awkwardness there, at least in my head, would be is today there is no like after authentication is done, there isn't really a concept of who authenticated it, right? And what this describes is like a filter on top of that. Um,
Which we don't really need after that. It's more a before thing.
I don't think I followed what you just said.
Like if you when the request comes in, it's basically going to be we have to tell the authentication mechanism. This is also the IP it's coming from. And so there's a configuration check to say, okay, for this authenticator, does this valid over this network?
Right. So that's what I'm saying, right? When you say this authenticator, authenticators don't have like names. They don't exist outside of
I see.
like being used, right? So they're not projected outwards after the fact, right? So you have to so a like a generic filter would just know the result of all of authentication, not who did it, right? So you would have to have some mechanism for either saying that now all authenticators within the system have like some identifiability and somehow
Yeah.
pieces of the system are going to be able to know that. Like for example, I don't think I'm inclined to say that like RBAC or VAP can know which authenticator did it.
Right.
I don't want people writing policies against that, right? So it can't be part of like user info. because that would
Sure.
go up all to there. So it would have to be something else. I think something basically new that would describe that. And it would be not just like I don't think it would be just the authenticator, right? Because when you configured like the CA bundles for client CA, right? All of them get bundled together, and all of them are valid,
Today they do.
and that's
Yeah.
one authenticator, right? So it wouldn't just be, hey, the X509 authenticator validated the request. It's like the X509 authenticator validated this request using this CA.
Correct. Yeah. So
So
there'd be some refactoring here to say like different CAs would be identifiably different. Correct. Yeah.
so I think that's probably what you would have to kind of spec out. And I guess like I'm looking at you to hear, right? Like I guess the pod search stuff would also now have a special name or something.
I mean, we haven't written any of that yet, so I don't.
No, I mean, but I assume if we're saying that now we're going to be able to have sort of a policy on top of the outcome of authentication that's named based on like authenticator plus configuration or something, the pot stuff start naturally flows out as a thing that will have that. So yeah, I think maybe that's what I'd ask for next is like maybe a one pager on like what that might look like with like maybe some pseudocode thrown in.
Okay. Cool.
Cool.
I think we're 6 minutes past time, so but thank you everyone. See you all again in 2 weeks.
But yeah, take care.
Thanks.